Looking at the lines and triangle unit pretest. And for the first page here, we are asked to give the name of the relationship, either corresponding, alternate, exterior, whatever it might be, and also write an equation that relates the two angles in question. So first one, we're given angle 2 and angle 3 here. And these two angles together are 180 degrees. Together they form a straight line. And whenever two angles are adjacent and form a straight line together, they are called a linear pair. So first one is a linear pair, and we would say angle 2 plus angle 3 equals 180 degrees. Next one, we have angles 3 and 5. We have this one here and this one here, and those two are opposite sides of the transversal, and they are both interior to the parallel lines. So that means that they are alternate interior angles. Now, alternate interior angles are always going to be equal, and you can kind of see how they're both a little bit bigger than 90 degrees in this picture. That's not a good rule of thumb to always trust that, but when they're slanted like this, sometimes it helps to look at it. So angle 3 is equal to angle 5. Third one here, we have angle 6 and angle 8. So angle 6 and angle 8. These two angles are opposite each other on a single intersection, so it is not something that relates to parallel lines at all, but it is called vertical angles, and vertical angles are always going to be equal to one another. Think of it like a scissor. If you open the scissors wide with the handles, the blades open wide too. So that is vertical angles. Next one, angle 1 and angle 7. And those two angles are on opposite sides of the transversal, alternate sides of the transversal, and they are outside the parallel line. So that is going to be alternate exterior angles. And alternate exterior angles are always equal to one another. E, we have angles 2 and angle 6 here. So angle 2 and angle 6. Those two angles are in the same spot, and they are in fact equal because they are corresponding angles. So they're same side of the transversal, one's above, the other one's above, they're in the exact same spot. That's called corresponding. And then finally, the last one is angle 4 and angle 5. We have angle 4 and angle 5. They are on the same side of the transversal. They are both inside the parallel lines, so that is same side interior. And whenever you have two same side interior angles, you can see they don't look like they're the same. They're not. They together add up to 180 degrees. Let's jump down the second page. We continue these angle relationships. Right here it says find the unknown angle. I also want you to find the unknown variable. And the relationship, name the relationship between the angles. So the name here is same side, because they are the same side of the transversal, and they are both inside the parallel line, so same side interior. And the angle relationship is that they add up to 180. So since I'm given one of them, I can just subtract to get the other, and I will find that the missing angle is 75 degrees. Next problem, we have a bunch of extra stuff going on here, and I find it confusing when there's too much stuff on the screen, so I'm going to get rid of some of it. So I see that I have an extra line right there, so I'm going to erase that one. And I have another irrelevant line going over this way, so I'm going to get rid of that one. So now that I've simplified my picture, I'm going to go ahead and try to solve it. I have angle and an angle, and those two angles are alternate sides of the transversal here, and they are both outside the parallel lines, so that is alternate exterior. Alternate exterior angles are equal, so that means I can set these two things equal to one another. And if I add 2 to both sides, I'm going to get 72 equals 12x, divide both sides by 12, and I get x equals 6. So alternate exterior and x equals 6. Last one, we have two angles here that are on the same side of the transversal and inside the parallel lines. So that is going to be same side interior. And same side interior angles add up to 1. And I lost my screen there for a second, so I wrote out the problem right here. You need to say the two parts add them together and equal 180 degrees. After you work through the algebra, you're going to eventually get to x equals 3. On the third page here, we're asked to do a couple things. We're asked to write the name of the angle relationship, if there is one, and then we're asked to say which lines are proven parallel if that relationship that's given is true. Does that relationship prove anything? So we'll start out with A. We have angles 15 and 16, and those two together are a linear pair. Now, when you have a linear pair, we only use one intersection, so that does not prove any lines parallel. So we would just put none for lines proven parallel. Second one, we are given angles 14 and 9. And 14 and 9 are corresponding. And corresponding angles are supposed to be equals, and they in fact are equal. And when they are equal, we have this transversal here, which means that we have these two lines that are being made parallel. And the names of those lines, now I covered them up, but is M and P. So we would say that lines M and P are parallel to one another. The third set of angles here we have is 14 and 4, and we have 14 and 4 right here. And those two are on the same side of this transversal, and they are interior to the potentially parallel line. So we would call that same side interior. And same side interior angles are supposed to be supplementary. They're supposed to add up to 180 degrees, and the statement says, hey, it does. So that means that we get that this transversal cuts across these lines being line R and line T. So R and T are made parallel by this. Next one, we have 3 and 16. So 3 and 16 here are alternate exterior angles because they're alternate sides of that transversal and they are exterior to the potentially parallel line. So alternate exterior. We also then have our transversal M, which means, again, R and T are made parallel. Next one, we are looking at angles 15 and 5. Angles 15 and 5. Those two angles do not have a transversal that cuts across to connect them. So they are in totally different, unrelated intersections. So that means there's actually nothing we can do with those. They don't even have a name for angles like that. So we're going to go ahead and just say none for this one. Number 6, we have angles 4 and 6. We have opposite sides of the transversal line and inside the potentially parallel lines. That is called alternate interior angles. And alternate interior angles are supposed to be equal. These two are equal, and so we would say that it makes these lines that the transversal cuts across parallel. So M is parallel to P. Next one, we have angle 11 and angle 9. Those two, like the first one, we have another linear pair here. Linear pair only deals with one intersection, so no parallel lines are being connected, so that means that it is none once again. Next one here, H, we have angle 16 and angle 10. We have angle 16, we have angle 10. Now those two angles are alternate same side exterior, they are on the same side of the transversal exterior to the parallel lines. Same side exterior should add up to 180, should be supplementary, and we can see from this relationship that they are equal. So we have same side exterior, but they're supposed to be supplementary. We're given something that's equal, no good. So we don't get a parallel relationship out of that. So be careful. There's a lot of problems where yes, these do have a relationship, but not this relationship. Next one, I, we have angle 4 and 5 is 180. So 4 and 5 here, those are same side interior angles. and same side interior are supposed to be supplementary, just like same side exterior, and in this case they do add up to 180. So we do get parallel lines. Now we have a transversal T, which means that we are connecting lines M and P to be parallel. So M is parallel to P. Finally, last one, we have angle 7 and angle 9. So we have 7, 9. Those two are going to be corresponding. They're in the same position in both sets here. Our transversal is P, which means we are connecting lines R and T. Corresponding angles will give us parallel lines, so corresponding, and we have R is parallel to T.